Good morning, everybody. Welcome back to lecture number 11. So, I'm going to walk over what we did in chapter 2 so far. Quick review. We did resistances in series, in parallel. They are in series. Looking at these terminals, they are in series. They are in parallel. Looking at this terminal, if I put a voltmeter, everything will have the same voltage because they share the two nodes. Okay? We studied how to find series and parallel resistors. Then we did network analysis using series and parallel equivalent. And we said this is an extension of chapter 1. We simplify the circuit and we do KVL, KCL. We also did study the voltage divider rule, which is the voltage gets distributed proportionally, that the value of the resistors increase, then we will have more voltage drop. Then we studied current. Then we studied current divider rule, right? And we said if you have two resistors in parallel, you can use this formula. And if you have R2, if you want to calculate R1, I1, you get R2. If you calculate I2, you get R1 over the summation. If you have more, you use the general formula, right? Then what did we study? We study node voltage analysis, right? We said the keynote about node voltage analysis is we get the current out of the node is 0. V1 minus 0. Mishal, if you can see, you can come closer. لا أنت قاعد تسوي كذا بعيونك. You should come closer. بالراحة. V1 minus 0 plus IS plus V1 minus V2 over R2. You do the same for node 2. You do the same for node 3. And we said node voltage. If you have a voltage source, then this simplifies the problem. Okay? Standard form. Don't forget the standard form. Then we studied the mesh analysis, and we said the key about mesh is you have to look at the loops and you create fake current IA and IB, IC. And if you have a current source, this simplifies the problem. Then, last time, we talked about Thevenin equivalent and Norton equivalent and source transformation. So let's review them. We said if you have a spaghetti circuit, you replace it with a voltage source and a resistor. We call them R Thevenin and B Thevenin. And how to find them? What did I tell you? You have to first find R Thevenin to save time in the exam. In case you fail to calculate V open circuit, you eliminate choices. That's a technique, okay? Then you find V open circuit, and we said V open circuit of the spaghetti. We call it open circuit because we're measuring across the open circuit of the spaghetti. Okay? We did some simple example here where the open circuit was nothing but a voltage divider between R2 and R1, because all the current will go through I2. There is no current that will go through these hanging cables. We calculated R Thevenin by shortening the voltage source, replace it with a line, short circuit, and R Thevenin looking that way, it's R2 parallel with R1. And then we find a Norton equivalent. Norton equivalent is nothing but you find a short circuit current. And one technique to find Norton is just find Thevenin and do source transformation. So if you don't want to do short circuit current calculation, another trick is to find Thevenin. Once you're done with Thevenin, just convert it. Let me repeat one more time. Two ways of finding Norton. Either you find the short circuit current by actually short circuiting the spaghetti. The spaghetti تحط لها short circuit. Another approach, you find V Thevenin and you just do source transformation. Get it? We did an example here. We said by finding the short circuit current, you're killing the R2. Because 0 parallel with any resistance would be equal to 0. And the whole current here will go through the current source because the short circuit, because electrons are smart. They go to the least path of resistance. You have a voltage source, V1 over R1, you get I short circuit, and this way you find short circuit current, which is the Norton equivalent. You can find V Thevenin and do source transformation. R Thevenin and R Norton are they the same? So you can calculate R Thevenin by R2 parallel with R1, which is R Norton, the same. We did another bigger example where when we find the Norton equivalent, in this example last time I solved it, to find V open circuit, I did a voltage source, a node voltage. So it's a V open circuit minus 20, V minus 0 over 20, minus 2 amp equals 0. One variable, one unknown. We find V open circuit. R Thevenin is you remove the current source, you short circuit the voltage source, which is 20 parallel with 5, which is 4. Okay? If I add a resistor here, will V open circuit change?
No.
Why?
It's a hanging.
It's a hanging resistor في الهواء. Okay, is R Thevenin gonna change?
No.
Yes, it will change. Let me explain this trick. Okay? Set this circuit. I need to get new pins. I said if you add a resistor here, okay? Will R Thevenin change? Of course it will change because you're looking here, صح? So R Thevenin will be this resistor, let's call this R1, R2, R3, will be R3 in series with the parallel combination between R1 and R2. How about V open circuit? Will it change? What you do to calculate it is actually the voltage drop here is called VOC, right? Is there, and then when we are professional, right? To calculate the voltage, we need to put the signs. I said you can say plus minus, plus minus, plus minus. What is this current, ya shabab? It's 0. So voltage drop here is 0. It's a hanging cable. So if I go and measure the voltage here, it's same as here because this is an open circuit. So V Thevenin for the trick equal to V Thevenin on the board. Get it? This is one of the questions in Dr. Atiyah's slides. I know you have Dr. Atiyah's slides. And I think the example was 4. Now, I don't know, it came up with me because I looked at these slides. Get it? Remember, hanging cables, if you find Norton equivalent and you do short circuit, the short circuit will change. Because short circuit is not a hanging cable anymore. Cable الصح? Get it? Source transformation is a technique. If you don't want to do short circuit analysis, you're lazy or you're scared in the test, you can find Thevenin equivalent and just convert it. The direction of the arrow matches the direction of the battery, and the Norton current is nothing but VT over R. VT over R. You can also convert backward. Source transformation is another way of solving problems, and you can simplify it back and forth. We did an example for source transformation here, where we transformed the Norton equivalent to Thevenin, and then we calculated I1 to be 20 minus 10 over 5 plus 10. Get it? If you don't want to do it, you can do a KVL, draw the man clockwise, then you can calculate I1. So source transformation is another technique. So node voltage is a technique, mesh is a technique, source transformation is a technique, Thevenin and Norton is another technique, chapter 1 is technique, parallel series is also another technique. So all these techniques, if the problem asks you to do a technique, follow the problem. It's meant for a reason, either because it's easier or because the answers should be written in the standard form, for example. Okay, any question about the review? So now I reviewed chapter 2 in 15 minutes. Maximum power transfer. Maximum power transfer tells me if I have a spaghetti circuit, maybe it has a battery here. What is the optimal value of a load, R load, that if I connect it to my circuit, I'm going to extract the maximum power from the voltage source that's in the spaghetti? This is a very important concept. Yeah.
Equal to R7.
It's equal to R10. But why? I'm going to show it to you. In mechanical engineering, have you ever heard about the concept of maximum power? Maybe in thermodynamics? Anyway, they say how to extract the maximum of the heat sink, and how to extract maximum heat, how to make the maximum pressure drop. These are things, and to be honest with you, to maximize any function subject to a variable, this is everywhere. You need to take the derivative of that function with respect to that variable, and you equate it to 0. This is Math 201.
Actually,
101 too, but in 201 you do calculus of yeah. I hate math, to be honest with you. I'm not good at math. I'm very weak. Very, very weak. Machine learning is nothing but this thing. It's a scam, by the way. No, not a scam, but machine learning is nothing but equating derivatives to 0, and you move in the direction of the minimum or the maximum of the function. And then they say, oh, the gradient, kernel. And they bring these names, but it's all Math 101. Get it? Get it? Jihad? Okay. So the maximum power transfer is if I extract the current IL from the spaghetti, if I convert it to Thevenin, it should have the same behavior. So the current is Vt over Rt plus R load. But the power is plus I square RL, because it enters from the positive. Passive sign configuration, don't forget. Applied to power, applied to Ohm's law. Yeah?
What if I connect the short circuit at the open?
This is, you're wasting energy. You're not, if you connect a short circuit here, this will be, of course, let's say that this is removed. So instead of R load, you connect a short circuit, you're burning electricity for nothing. You're not going to benefit from it. If you connect a resistor, which can be a lamp, which can be a fan, it's better. Remember the example of the battery?
Yes.
If you connect a short circuit to a battery, you're wasting it. And this happens very common. If you put two batteries head to head, then you try to connect a new battery. That's why you need to store your batteries in a very organized way. Same concept.
But the current will be maximum, right?
Yeah, but I don't want the maximum current. I want the maximum I squared times R. So if you connect a short circuit, I squared times R, if the short circuit is 0, the power is 0. What's the power dissipated in a short circuit? Again, I squared times 0. What's the voltage drop across a short circuit? IR, I times 0. The math should work. Now, the power, if you substitute IL, Vt over, you will get Vt square over this term square. To calculate the maximum power, I'm not going to do it. Go to Math 101, go to Dr. Al-Hamidi. You know Dr. Badr Al-Hamidi?
Yes, sir.
He taught me Math 101. Very good instructor, very smart. Ask him how to do it if you don't know how to do it, or ask whoever taught you Math 101, maybe Dr. Azam Faraj. Anybody study with Dr. Azam? You study with Dr. Azam? Okay. Ask him, okay?
So the quotient rule. The quotient rule in...
The quotient rule, you got it. I'm not gonna do, I don't know what is this, I forgot.
You square the denominator.
Yeah, you square whatever. It's not, what's important is once you do the equations, you will find RT plus RL equals to 2RL. This implies RL should be R Thevenin. And you got it right. So R Thevenin is the one that gives you the maximum power. And how to calculate the power? P equal plus I square R L, and we said I square is what? VT over RL plus RT, you square it times RL. But we said RL equals to R Thevenin, so if you plug them, it should equal to VT square over 2R Thevenin square times R Thevenin. This will cancel with the square, so it will be VT square over 4R Thevenin. Get it? This I can derive for you. But this one, math is hard. It's embarrassing, but I don't know. It is what it is. What is the maximum power? What is the resistance that gives you the maximum power transfer for that circuit? Mentally. It's R Thevenin. What is R Thevenin? Short circuit, 5 parallel with 20, which is 4. And what is the maximum power? Is V Thevenin over 4 R Thevenin. We need to find V Thevenin. V Thevenin is nothing but 50 divided by 5 plus 20, which is 10. So maximum power is 100 over 4 times 4, 100 over 16. Easy? This is a tabulation. This is the tabulation of the maximum power. If you notice the column number 11, if we put R Thevenin, why it says 10? Because he changed this 20 to 10. What is R Thevenin? What is 20 inverse plus 5 inverse all inverse? 4, right?
Yes.
This is another example, ya Shabab. That's another example. What if R Thevenin is 10? What if V Thevenin is 10? Please, slide 49 is different than slide 50. That's another, this is calculation, tabulation. If R Thevenin and R load, they are equal, you get maximum power of 2.5 watts. If you go up below RL, it decreases up until you reach RL equal to 0, where you get 0 power. If it increases, if you're becoming so needy in life, then you will consume less power. So to extract the maximum, you have to be right around Thevenin, okay? And this is applied for many concepts in engineering. Is not the biggest value is always the best. Sometimes something in the middle is what gives you the most. Get it? So any question about this tabulation? You might do this experiment in the lab by having a resistance that is variable, and if you change it, you will find the power, and then they will ask you to plot power versus RL. Ibrahim, get it? Okay. You will study this, okay? What it says, read if interested. I'm not interested. Do you want me to do it?
No.
You want?
No.
Yeah, let's focus on the ultra checkpoint. This is a checkpoint that is ultra. Yes, this is not an easy example, but we have to learn. It is what it is. This example is also from Dr. Atiyah's slide, not from the book. And it looks like an old example. The question is find R Thevenin. السؤال هذا ملغم يا شباب. السؤال هذا ملغم. So don't panic. You will learn from it many things. We are professional, we have to draw the circuit, صح? Let's draw the circuit.
There is cancellations.
Yeah, because you watch the videos and now you know how to solve it.
That's what.
Because you focus on the lecture. So I'm going to block your account on YouTube. Send me your account. Block it. Just kidding. So we are professional, right? Let's do it. Oh, that's not a good pen. What did we say? These are the terminals. Yeah, I know it should be white dots, but that's okay. This is from another book, or it could be from the old exam. We have a resistor. We have a current source. We have a 15 ohm here. Oh, this one would cause us a trouble, the 4 ohm resistor. The 4 ohm resistor. The 40 ohm. The 26 ohm. The 0.1 amp. The 10 ohm. What else? 15 ohm. 14.7, 17.4. Ugly number. We don't like. We like 120.
The 4 ohm.
Where is 4? Oh,
No.
4 ohm. What did I tell you? You professionals, right? Is it marked? No, we have to mark it ourselves. So let's do our best. Let's say that there is a current that enters here. We're going to call it plus some minus. A current enters here. Note that I did not name them for now because I don't know which method I'm going to use. So you can call them I26 ohm, I40 plus minus I15 plus minus I10. Yeah, I think, and then maybe this I10 would go this way. So here, if it's at the bottom, I told you to make it plus minus. So that the current, you would trace it, okay. If this is open, the whole I10 would go here. So this is I10, the same. Is everything now marked and ready? Many students will start doing node voltage analysis, but the question doesn't ask about that. It says find Thevenin and Norton. What should we start with? Norton. Find Norton. Find Thevenin. This is expired. Probably we're going to use blue for now. We don't have it. What is Thevenin? Thevenin, redraw the circuit. That's a 10. Open the current source. That's a 26. That is the 15. That is the 40. You short circuit the voltage source, right? And you look at your Thevenin. Thevenin would walk and apply an ohm meter here, which is like applying it there. The key here is applying it here.
We have resistance.
Oh, the 4 ohm. Okay? So keep in mind that he is looking that way. He is looking this way. He's looking that way and that way. He's not looking only using, no, he's having the voltmeter in the lab. The ohm meter has 2 terminals, right? So 2 terminals here too. So what does he see Thevenin? That's a trick question. A smart student will tell Thevenin, hey Thevenin, we have 15 and 40 in series. Why? Because ما في أحد يخرب عليهم في النص. However, both terminals of the 15 and 40 are short-circuited if we... So what do? Kill them. Get rid of them. Don't distract yourself. They are not zero. They are the electrons. All the electrons will move here. None of the electrons will move across the resistor. So just delete them. Or you can say, you missed, Father. What did we say is, once you redraw the circuit, we have a short circuit. 15 and 40, they are shortened with the voltage source. So if you, and this is open, so 15 and 14 series in parallel with 0. It means you just keep the short circuit. Get it? Get it? Get it? واضح? If you parallel any resistors with a short circuit, what will happen? Short circuit. Nasrallah? No, Abu Nassar. Where's Nasrallah? You always... I get confused. In Ramadan, you always sit here.
Yes.
Sorry. I got confused. I called you Nasrallah in last lecture.
Yes.
خلاص, you're Ramadan. Okay. 2 sections. So you have 4. So what will happen here, in the eyes of Thevenin, is 10 in series with 4.
No. Does not see it.
He doesn't see them as series. Remember, this is a closed square. So in the eyes of Thevenin, he sees 10 in parallel with the 4 and 26.
How?
Because he is measuring the resistance this way. So this is 10. If it happened you connect any load here, the current will go here and then it will split. The key here is when you look at our equivalent, you have to assign 2 terminals to look from, صح? By assigning Thevenin terms, you're seeing the 10 in parallel with 4 and 26. Can I redraw it this way?
Okay.
4 plus 26. And this is for kids, 10 parallel with 30. What's the answer? Who didn't bring the calculator? You did not bring the calculator.
7.5.
Yes.
Who didn't bring the calculator? Who wants a calculator? مش هالغام. You didn't bring the calculator. Get it? The trick here was knowing that 4 and 26 are in series, more parallel with 10, and the short circuit would cancel some of the resistances. Done? Done. Let's do a tougher. So our Thevenin is what? What is our Thevenin?
7.5.
So 7.5 ohms, and now forget about our Thevenin, go back to your original circuit. What do you want to find? V open circuit. What is V open circuit? It is this voltage drop across the 10 ohm resistor. How do you want to find it? Mesh, node voltage, or both methods?
Mesh.
Let's do mesh and then do node voltage. Because both are correct. Many students would think, oh, that looks like a node voltage circuit. If we do mesh, we have IA, we have IB, we have IC. Who wants to be the KVL for the mesh analysis? Hatem is the KVL guy. He will walk here. Hatem, please give me numbers if you don't mind.
Plus 17.4.
Plus 17.4. Now, before you do that, what's the current at I40? IA minus IC. It's IA minus IC. What's the current at 15?
IA minus IB.
IA minus IB. So, voltage rise, voltage drop.
Drop.
What do you put?
Minus.
Minus. What is the number?
IA minus
IA minus IB. But we put the numbers before, صح? We put 40 times so that we can get the code. ما تحطها في اليمين, تحطها على اليسار قبل أحسن. IA.
minus IC.
What's the voltage drop here?
Minus 16. IA minus IB.
Equation number 1, your equation. Who wants to be another KDL? Muhammad Al-Khaldi? Which loop? Pick a loop.
The down. The right down.
That's why we're going to fall into trouble now. But that's okay. Before we do that, do we have a problem?
The current.
We cannot calculate the voltage drop across the current source. So what does that tell me?
Will not work.
It will not work. The only way it works if we create what we call it a super mesh. Super mesh, it covers the whole thing. Okay? So super mesh, if you mesh around the bigger loop, and then you bypass, but I'm not going to do it for you. Okay? So clearly, as with the way we studied, we cannot do mesh analysis. Why? Because we don't know the voltage drop here. How to fix it, try to do it at home, or maybe once we finish the node voltage, is you do a super mesh. So you have to walk here, 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 go back here. And then you will calculate, you write everything in I, A, and then the last equation will be what? 0.1 equal IB minus IC. That's the super mesh. I'm not going to do super mesh so that you don't get confused. Maybe I'll do it at the end of the lecture or maybe in the office hours. So Hatem, sorry, we reviewed mesh, but we're not going to use your mesh. So then what's the alternative? Node voltage. So node voltage is now more appealing, صح? Is super mesh part of the syllabus? No, right? خلينا نحذفها. إذا هي بترجع, I will make a YouTube video and I'll explain it to you. I have to check with Dr. Atiyah. Okay, Hatem? If super mesh is part of the class, I'll create a fake lecture, a new lecture, and then I'll put it on YouTube and share it with you. My own lecture. Goodbye, our mesh currents. How many nodes of voltages?
3 nodes.
So we know this voltage, so we don't need it. So we have this, and that. Forget about open circuit. We have V1, we have V2, we have V3, صح? Forget about V open circuit. 1, 2, 3. This is known, 17.4. This is the ground. Is this the ground?
No.
So this is a node. This is a node. This is a node. Is there any other node? This one we know it. So we have to do IA, IB, IC, ID, IE, IF, IG, Instagram, IH.
مو المفروض V3 تكون كلها مع الجراوند صفر؟
No, because V3 and the ground are separated with the 4 ohm resistor. That's هنا الترغيب. هنا التريك.
احنا ممكن بالاختبار يعني يعطيني نفسي بالصورة كل النويز كبيرة بس انا احددهم اللي هو هنا مسكر خلي
Well,
ما في
there is a fake node.
اي
But في الاختبار I don't know. Depending on Dr. عطية. إن شاء الله بلحق عليه أقول. Okay.
صار على أي أساس حددت إنه هذا مكان الكون؟ ليش مو بعد الفور ريسيستر؟
Here,
لا بعدها.
here. Because this is the ground is the same as this point. You can put it here. It's the same thing. This is the same node. You connect them with a cable.
بس ليش اخترت هنا؟
Because you have to pick a reference in your circuit, and the trick here is it's usually connected to the negative sign of the voltage source. So let's do it. IA plus IB plus IC equals 0. What is IA? V1 minus 17.4 over 40. What is it? IB? V1 over 15 minus 0. What is IC? 0.1. Who wants to do the second node, which is this node? We want ID, IE, IF. ID plus IE plus IF. Ramadan. What is ID?
Negative 0.1.
What is IE?
I use V3 minus 17.4 over 26.
What is IF?
V3 minus V2 minus V3 over 10. I mistake the second one. It's V2.
Okay. So this is V2, sir.
Yes.
V2 minus V3.
Over 10.
Who wants to do IG plus IH? Note that here we only have two currents, but that's okay. Abdul Majid, where is IG?
V3 minus 0 over 4.
Plus, what is IH?
V3 minus V2
Standard form, guys. I'm gonna erase this circuit. Is it okay? Khalas, we already wrote the equation now. Wanna do? No need to erase it. Let's do it. Let's do it at the bottom. Standard form. How many variables?
3 by 8.
What are the coefficients of V1? 1 over 40 plus 1 over 15.
0.0916.
What?
0.0916.
Are you sure?
Yes.
Are you sure?
0.09.
Okay, not 1.0. Okay, 0.091.
9.
6.
916.
Yes.
Enough. 3 digits of form. What is there any V2 or V3?
No, 0.
So we put 0, 0. What is the constant?
0. Minus 0.
Minus 0 point?
Plus 17 over 4.
Yeah, Shabab, we want the right answer.
Minus 0.1.
Minus 0.1
Yes.
Yes.
minus,
Ah, okay.
Minus 0.5.
you have this, 17 over 40 plus 0.1 equal, so it's minus 1 over 10 plus 17 over 40 over 40.
0.331.
I want another confirmation.
0.33.
Yes.
0.335. Okay. Line number 2. Is there anything for V1? For V2? 1 over 26 plus 1 over 10.
0.138.
0.138. How about V3? Should be minus 0.1. Minus. What is the constant? It's not, you're forgetting 17? Yeah, it's 17.4 over 26. Guys, this is over 26, not 20.
0.76.
Hmm?
0.69.
Okay. Father?
0.769.
Same. 0.769. The last one, it's 0, and then what's minus 0.1 for V2?
0.35 V3.
1 over 4 plus 1 over 10.
0.35.
0.35
Yes.
equals 0, right? There is no constant. System solvers, what is V1?
3.65.
3.65
What is V2?
6.96.
6 point.
96.
What is V3?
1.99.
So what is V open circuit? V open circuit is nothing but V3, V2 minus V3, right? What's the final answer? 5 volts. Roughly. Now, if we do exact numerical, this should be 9, 6, 7, 7, whatever, and then this would be 5. Final answer is 5. ملغم صح؟ This way sometimes chapter 2 becomes very helpful. But I'm gonna do it with node voltage. We don't have time to do mesh. Next lecture, again, let me explain this one more time. For our Thevenin, we said it's 10 parallel with 4 plus 26. Get it? Which was 7.5.
Parallel for 4 and 26.
10 parallel with 4 plus 26, because short circuit will cancel 14 and 15.
How is it parallel?
Because they share the same two nodes. This node four. This one will be gone. This will be open. This one will be gone because it's a short circuit. So it's 10 parallel with 30. Then you do Thevenin. We tried mesh. We don't know how to do it. We started using mesh analysis. Then we realized we can't calculate the voltage drop across the current source. How to fix it? Use a super mesh, which also has 3 equations. We didn't cover it yet. Maybe we'll cover it next week. Then we don't know how to do it. We have to use node voltage. But this node voltage is not easy, because you have to know which voltages you don't know. You know this node, you do not know this node, you do not know this node, you do not know this node. You have to assign the ground here because it's in the negative of the battery. Yeah, we want to know V open circuit. Remember in the node voltage we calculate Ix equal V1 minus V2 over, remember? It's the same thing. V open circuit is V2 minus V3. Then you have to set up the equation. IA plus IB plus IC is V1 minus 70 over this resistance, plus V1 minus 0 over this resistance plus 0.1. It's the first equation. The second equation, it's minus 0.1 plus V2 minus 17.4 over 26 plus V2 minus V3 over 10 equals 0. It's this equation. The last one is Ig plus IH, which is V3 minus 0 over 4 plus V3 minus V2 over 10. Then you have to do the standard form. We wrote it in the standard form. We notice there is too many zeros in this standard form because there is not much dependence between V2, V1 and V3, for example. But there is a dependence between V2 and V3. So you can see V2 and V3, they're more dependent than V1, which is a standalone. This means you can calculate V1 without calculating V2 and V3, because 0.0916 V1 equals 0.335. So V1 is 0.335 divided by 0.0916. Math 002. Did you study the rank of the matrix? What's the rank of this matrix? Not really. It's 2. No, it's 1. Because those are dependent. 2. Whatever. Fine. I don't know. But you will find 2 and 3, they're dependent of each other.
So 3.
Is it full rank?
Yes.
I don't know. Allah.
It's,
Don't quote me. I don't know.
then 0.
I'm not a math teacher. So go to Dr.
The
Hamidi.
determinant is not 0.
I don't know. I use MATLAB and then I put rank. Now, we solved this, we found V1, V2, V3, right? V open circuit is nothing but V2, V3. So V Thevenin is almost 5 volts. R Thevenin is 7.5. Why are you rushing? You still have 1 more minute. If you want to leave, you can leave, but you should have left earlier if you want to leave. Next time, we will cover superposition principle. And we will cover Wheatstone bridge. قنطرة Wheatstone. درسناها بالفيزياء? Did you study it in physics? And this will probably end the material of the major exam. This will be hopefully finished Thursday. Any question? We'll have the quiz.
Are there any possibility to postpone the quiz?
No. All sections will have a quiz on Thursday. We may bring this question for the quiz. No. The quiz will be one section will have node voltage, the other will have mesh. But you have to study today's lecture because we did node voltage today. Yeah. 12 minutes. 12 minutes to do node voltage. Okay, let me stop the recording.